My name is Brian Watkins, and this is the 5th video tutorial for Accounting 231. We're going to prepare a spreadsheet that provides a graphic demonstration of calculations of the value of an ordinary annuity. We're going to use both Excel and regular mathematics to figure out this amount, and then we're going to show it by way of two tables and a graph. So we'll begin. This project's called the present value of an ordinary annuity. And you'll recognize that what the annuity is because I have provided some study materials that I've asked you to clear before starting this video. So hopefully you remember that the annuity is simply a regular series of equal payments into an interest-bearing account. So this spreadsheet will provide a graphic demonstration of the correct calculations of value pertaining to an ordinary annuity, one in which payments are made at the end of the period. Remember, there's two kinds of annuities: annuity due, where the payment is made right up front, and an ordinary annuity. And you need to know the difference because the ordinary annuity does not receive any interest in the year from the payment. The payment's made at the end of the year. So let's use our row 4 skills here, and we'll go out to G. Let's merge, wrap, top align, right justify, pull this down. Okay, and our data section is designed to provide the inputs required by the Excel function, which has 5 arguments. So let's get our section bar here. Okay, our 5 arguments are annual interest rates, the periodic payment amount, the future value, the number of periods, and the type of annuity. And we prepare our variables by highlighting the names, going over one column, and doing Control-Shift F3. We'll create our names. Done. Then we take those cells that contain our names, Control-X to cut them, Control-V to paste them. So now they're ready to go. Let's widen our screen a bit. I'm going to use, I think a 13 would be a good start. Okay, now I have ordered these in different order than the actual formula will accept them, because I want the first 3 to be the ones that our user can enter, and then these last 2 are going to be fixed. The number of periods for our exercise is fixed at 10. We're hard coding this because this is more of a teaching tool than something that we're going to use in real practice. Type of annuity is going to be a 0, and to the side we'll say 0 equals ordinary annuity. Try to leave your user some clues so that they're not wondering, what do you mean by type? Okay, so with these 2 fixed, they're not going to change. They don't get a colored background, but these 3 will change. So we're going to go to our sample test. Looks like we're going to have 10.58. That will be, whoops, 0.1058, because that's going to be centered, and it's going to be a percentage. We need to give it those 2 decimals. Okay, periodic payment amount is going to be a large number. I will explain this number as we go forward. So we will copy that. Oops, I messed up my copy. Okay, so copy, and then paste. This has to be a negative number. Okay? A negative number means that it's money that we're paying into something. You'll find your 12C, your HP 12C calculator works the same way. And one of the things we're going to do in this unit is to explore ways to provide a rule so that your user can't mess up the formulas that you provide. Like I just messed up that one. Okay, let's go back. Escape. Okay, remember we've got to put a minus sign there. So I hit enter. Future value of the annuity going to be 333,000. And that is going to be a currency. Let's center that. We'll center the amount, make it a currency as well. But I want you to remember it's important that you put all those decimals in. And I'll show you why in a bit. Okay, now our answers. The answer section here is going to be quite short because we're really not asking a very difficult question. We're asking for the present value. Let's use a green here. The present value of the annuity. And that's simple enough. Present value. And then we're going to ask for a future value. And let's do this. Let's give ourselves a little more room. Let's take these X, Control X and Control V. So I've moved those over. And I'm going to move future value over to here. Alright, let's take a look at our output. Okay, we're going to need to shrink that up a bit before we go to print, but we're still on the page. Okay, so we're going to have a present value, we're going to have a check figure, and I'm introducing the concept of a check figure here. Whenever we do something that's very significant, we calculate it in two different ways to make sure that we're calculating it correctly. But the present value, let's name this cell here, is going to be present value. Okay, and here's another trick for you. Now that we have lots of named variables, let's say you get to the point where you want to check your variables, you can hit the F3 key, and F3 will bring up a list of the variables that you have named. That's always handy. Okay, present value is going to be the PV function, present value function. Functions have names, they have the equal sign. So equal sign the name, the open parenthesis, and then a box will show up to show you each argument or number that the function requires. The first one is rate. So we're just going to give it, well, it's not going to allow us to click, so we're going to go on F3 and we're going to paste the annual interest rate there. Okay, number of periods. That one's not working either. Okay, I think what's happened is that when we moved our names, annual interest rate blue is showing up there as blue. So let's go and fix that. Sorry about the error, but we fix naming errors, so we should be in column E. So we'll go to formulas, escape, name manager. Okay, somehow they all got into F, so I'm going to edit each one. Annual interest rate. Okay. Future value. Okay. Number of periods. Okay. Number of periods will be 10. Good. So, okay. Okay. And keep dumping this out. Periodic payment, F9. That's good. Type of annuity is going to be E12. Done. Okay, so now we should have everything right. So we'll do PV, rate, number of periods. Now you can see how it's out of order. but I did that so that the first three are our numbers. Payment, that has to be negative. Future value, and then the type. Now look again in your box. At any time when you look at a function, you can type on the argument, you can click on it, and the argument will light up. It'll be highlighted here. When arguments are in brackets, they are not necessary to the function, but can be included if you want to. So we could find present value with only rate, number of periods, and payment. But we're going to include future value and type as kind of a check. So we'll close this function. Right now the present value is 0, and remember what that means. That means that before we make any payments into this account, these periodic payments, the account is worth nothing, and we will come up to $333,000 at the end. So let's do that now. Let's do the future value and check if we're right. The future value has the same rate, future value has the same number of periods, has the same payment, present value from here. Okay, you saw the present values off to the left, and the type of annuity is also 0. And we're stressing that because this is always an ordinary annuity, payments made at the end. Future value 333. Now the importance is, in order to get that number, to get this future value to work just right, we had to enter this big old long sequence of numbers. So we're going to come back to how you figure that number in a moment. But for now, let's just draw out as if we got the number the right way, and we'll complete our table. Let's make it fit. So squeeze that a bit, squeeze that a bit. Okay. So there's our check figure. Now, we have our answers, but we're not done. What we're going to do is prepare a proof. And the first proof we're going to do is backwards. Okay, we're going to come at this, and we're going to calculate this annuity. So we'll give this a yellow with, and we're going to prepare a table. The table will have period, end balance, payment, interest, beginning balance, and then a check figure. Okay, we're going backwards, so when we go backwards we start at the end and then we go forward. So we do bold, underline, center. We need a little more for our check figure there. And we're going to hard code the periods. Remember I told you that this was going to be a little bit different kind of spreadsheet. So we're going to start at 10, 9, and have a 0. And let's center our numbers so they fit. Okay, our end balance, well, we know what our end balance is because we're going to be using the future value. Okay, so whatever the future value is, I don't think we've named it yet, so we'll take the future value, name it, and we're going to start with future value. Now be careful with this. Whenever you have your numbers coming down into your spreadsheet calculations, bring them down once. Okay, if I were to copy this down, that would mean that this cell pertains to each one of those cells, and we don't want that because that will freeze our table. We won't have the right numbers. We only want to do this once. So we'll start our table, and we'll start it with that 333. So let's format that one. Now the payment, we know that we're going to start with 333,000. That's our future or end value. So we're going to subtract from that whatever we paid at the end of period 10 in the annuity. So that means that this has to be a negative number, and fortunately we've already defined it as a negative number, so when we go up to make it a comma format, it will put the brackets around it. Now the interest is calculated in a different way. Now here's where we're going to get somewhat calculating. Sorry, erase that. The interest is just calculated. We're going to do the beginning balance and we're going to multiply that times the interest rate. This is an annual rate, so we don't have to have a fraction. Okay, that will be 0 until we can come up with the beginning balance. The beginning balance is the one that's tough for students here, because we're using a discount formula, not traditional discount, but discount in the sense of we're taking a present value back in time. So the way you do that is you start with your ending number, and your ending number here is going to be the end balance less the payment. Now, even though I'm saying less the payment, because payment is a negative number, I'm going to add it. But I want you to be certain in your mind that you understand that what we're trying to find out is that payment came in right at the end of the year. So $333,000 minus $2,320 was the amount we had with the interest earned during the year. And then instead of multiplying it, we're going to divide it by 1 plus the interest rate. Okay, we'll go over this in class, but the formula is the ending amount divided by 1 plus the interest rate. I'll show you how to derive that on the chalkboard, but for now, just remember that. Okay, so when we do that, that tells us our beginning balance at year 10 was $282,000, and then we earned a certain amount of interest. That has to be a negative number because it's coming out, so we'll force that to be negative. So what we did is, if you take 282 and you add 29,916, then you add the 23,2040, you'll come up with the ending balance, but we're working backwards here. And so in order to check that, we did it one way. We went from a future value to a present value. So what we'll do is we'll do a check figure using the present value function. And of course the rate's always the same. And this is a one period calculation. We're just double checking period 10. So for all our check figures in the proofs, it's a 1. And the payment is always going to be the same. So we'll use the periodic payment amount. And our future value, what we come up with after that year, is going to be the ending balance. And then we'll use a straight 0 for our type. Okay, there's our check figure. Now if we were to add this check figure to the number we calculated for our beginning balance, it will disappear. So we will only see a result in the check figure if our information is wrong. And I want you to focus again. We start with the future value, we subtract the payment that was made at the end of the year, we subtract the interest that was earned during the year, and that leaves us with what we had at the beginning of the year. And then we start the next year with that balance. And we do it, we can bring these formulas down, and we have, actually we can bring the check figure down too. So we have our table. And if we bring this down to 1, everything's good. Now we have a year 0, and what do we want to put in the year 0? We want to simply put that F31, or this number here. We can't have any more numbers here. Oftentimes students will just copy it down using the autocopy, and you'll see what happens. If you copy this down, this number, and this number are meaningless. So watch out for that. Don't do that on the test. Make sure that you just end up with this 0. And what that 0 really is that is your present value detail. Because what you've done is you've started with your future value, and you've done, by regular math, you've subtracted out all the interest, and you've come to your present value. Okay, so now let's do this a different way. Let's do it the forward proof. This is the one that's typically a little easier for students to understand. We're going to start with period, but then we're going to have the beginning balance, because we're going to start at the beginning. When you go forward, you start at the beginning. When you go backwards, you start at the end. We'll have a payment, we'll have interest, and we'll have, sorry, the ending balance, and a check figure. Okay, so let's format all of these the way we were used to formatting. Bold, underline, and center. We're going to start with a 0 this time, and in at 10. Okay, and this time again our 0 line doesn't have balance, payment, or interest, but does have an end balance, and we're going to use present value detail. I should be able to call that up. Present value detail. Okay, so it didn't remember my name, so I'll put it up. I'll put this present value detail. Okay, did it remember it this time? So we have present value detail. Now, why is there a number there? This is a decimal point followed by 10 zeros and then 2566. The reason for that is there's a tiny bit of rounding error in these interest calculations. So if you go to your comma format, it'll put that as a 0 for you. Okay, so our beginning balance is going to take the ending balance, and now we go forward. Our payment, which comes in at the end of the year, is going to be, since we're adding this time, we're going to say negative periodic payment amount to force it to be a positive number. So here we have year one. Year one, we're going to do our beginning balance times the interest rate to find out how much interest it made during the year. And as you can see, we didn't make any payment till the end of the year, so there was 0 interest. And then for our ending balance, it's simply a matter of adding everything up. And we'll use the sum function. We'll just sum up all 3 of these. And that's our ending balance. The way to check that is due to future value. We want to find what 0 is worth in the future at the end of one period at this rate. So I'll put in my annual interest rate. My number of periods is always 1 here because I'm only calculating what happened in this 1 year. Each row is 1 year, and each check figure at the end of the row will only involve 1 payment. Okay, and then our payment here, we can just click on we can either click on the payment, which has already been made positive for us, or we can click on periodic payment amount, but we have to remember to make it positive this time. Okay, so now we do, where's my box? Oh, box moved up to here. The present value is going to be the C38 column. So where's this beginning balance? There's our present value, and we want to find out how that, using a regular end of the period payment, will add up. And it comes to the right amount there, so that if I add to the end balance, it goes away. So that's the check figure. We calculated the future value of 0 with a payment at the end. Payment's always the same amount. It doesn't receive any interest. So at the end of year 1, our annuity is worth 20, 320, 40. I can take all of these now and copy them down, and I come to the end, and that's my calculated future value, 333. So let's go up and do our check figure for the major calculations. So I say, was my calculated future value equal to my future value from my Excel calculation? Yes, it was. We can do the same thing for the present value. Was the present value that I calculated here the same as the present value I came up with using Excel? And remember, just make that a quote and you're fine. So bear in mind that these check figures, if you've done it right, come from the same column. present value, future value, and future value. Once you have your math correct, and do not take this step until you have your math correct, you can format these as tables. And so what you do is you highlight your calculations and go to Format as Table. And we can come up with any one of the table styles here. So let's try doing this. Okay. And there it is. My data has headers, meaning it has these formulas at the top. So it's a little bit of a... There we go. Okay, so let's do the second one now. What you do is you highlight everything, including the headers, format as table. Let's use a green this time. There we go. My table has headers. And there's my table. Tables allow you to do interesting things. You can filter tables automatically by hitting the Filter tab. And I could say, just show me year 5. And it would shrink up to just show you year 5. Or I could clear the filter. I can sort based on these. Tables allow your data to be manipulated quickly. And if you ever need to take, for example, if you did a table on your data and then you realized, oh, my math is wrong. For example, you left your interest column positive here. It's harder to make changes now because you're inside a table. So you would highlight everything again, right click on it, and this time you would format it as a range. So let's see here. Table, convert to range. Okay, so that, I'll leave that on the screen for you to see, is how you would undo a table to fix your math and then put your table back together again. Alright, so we're out of that. So now let's go and let's do a graph. We want a graph that will show our investment account growing. So what we do is we highlight our end balance here. Highlight the whole thing. Go to Insert, and we want a line graph. So we'll insert a line chart. Just take the first one that comes up. And there's your graph. And just kind of put it down here between, you know that your page numbers there. So we've got to shrink up our A just a little bit more to get that check figure in. Okay, so here's our graph. And I want you to do two things to your graph. First thing I want you to do is to get the graph to start on period 0. What it's doing is it's taking data points, it's just counting them. So if we select our data, okay, right now it's starting with end balance and it's just using on your horizontal axis this 1, 2, and 3. So we're going to edit that, and our new axis label range is going to be 0 through 10, which will match. So I hit OK, and that bottom now, it goes 0 to 10. The reason for that 50,000 there is because of that tiny little negative that crept in. So I'm going to click on this one. I'm going to format the axis. This takes a little practice here. These controls can be finicky. Come on. Oh. Crash, crash. Okay. Now, it automatically selected a minimum amount for my axis based on that tiny little rounding error. I don't want to see negative 50,000. I want to see 0. So know how to go to your axis and fix that. You basically click on the data and then format your axis. Okay? And here you click on your data and you select your data and you go to your axis labels. And it's a little bit tricky, but I think you'll get it. Now, I don't want the name to be called end balance on both the title and the legend. Let's change this title to something that we could give to a client. We could say value of investment account. We don't need the extra line. So there you go. So that's value of investment account. As long as we're inside this chart, it's telling us that here are my labels, here are my data points, and I click out. So let's take a look at our information, and we've cut our table in the middle. So let's do some print formatting right now. We're going to get our row 4 just right, and then we're going to put a page break. So I'm going to highlight the forward proof there. I'm going to go to page layout, and I'm going to put a break. Insert page break. So now you saw the page break hop right up there. Now if I go and look at my output, I have one table and then another table. Now it would be even better if my second page had some information on it. So I'm going to go back into the work here. I'm going to go to page layout, print titles. These are the titles that come up at the top of the screen. Print area is a dangerous one. Do not define your print area. Instead, you're looking at print titles, and we want rows to repeat at the top. So we'll hit the select button, and we'll say please repeat rows 1 through 4 at the top, and then hit OK. While we're at it, let's do our footer, custom footer, do file path. Alright, now let's look at our print. Good. Everything looks good on that page. And then the next page. Okay, well, we need a space here, so let's figure out a way to get that space in. I think the way to do it would be to take our header, page layout, breaks. Let's reset all our page breaks, and let's put the bump ahead of forward proof, and put the page break at the bottom. So now I think we're good to go. Good. Now we've got our page break in there. So those controls found on page layout, just remember page break and print titles. Don't use the print area, just the print titles, and go through rows 1 through 4. Now, one last thing we're going to do in this topic, we talked about how important that negative is. If I take that negative out, nothing works. We get gibberish in our numbers. So how do I make sure that that number always stays negative? The way you do that is you insert a rule. So with that cell selected, go to your data, and we're going to go to data validation. And if you read the text, it says prevent invalid data from being entered into a cell. So we'll click on that, data validation. We're going to allow a decimal, okay, and it's going to be equal to or less than 0. Okay, so of all the rules you have, just remember it's the last one. Go to the end of the box, less than or equal to 0. Make sure you allow a decimal. If you put a whole number, then you're going to lose all of those digits, and those are necessary. Okay, so here we go. Those are the settings. Now we have an opportunity to show a message when the cell is collected. So on our title, we're going to say periodic payment amount. That will be the title of the box that shows up. Please enter a negative number in this cell. Positive numbers will not, well, it sounds kind of clunky. The formula requires negative numbers. That's about all we need to say. I could say more. I could say negative numbers symbolize the payment of money into an account. Alright, that's our message. Now our error alert, you have 3 choices. Stop, warning, which looks like this, or information, which is just the little I. We want a stop, which is the most important. Okay, and our title is going to be invalid data. If someone tries to do a negative number, if someone tries to positive number, positive numbers will not result in valid output. That seems kind of clunky. Why don't we just say positive numbers do not work? in this spreadsheet, in this cell. There we go. Okay, now when I hit OK, now because the cell is selected, you see my message. Please enter a negative number. Now, if I try to enter a positive number, like 1, the bong goes off, a little sound, and it says, positive numbers do not work, retry. And it gives me a chance to then satisfy the program. So now you're protected from somebody getting frustrated with your work because they forgot the rule that that has to be a negative number. Okay? Actually, currency is probably not the best format for that. Let's try a positive. Is that gonna work? General, center. It doesn't want to center that. So what is going on? Center. There we go. Okay, so we'll just leave that with that negative number. Now that is your data validation, and that completes the exercise. I believe that at this point you know what you have to actually prepare. There's one last factor that you need to be aware of, and that's how in the world did we find a number with, let's see, 9 decimal points. So let's come in, and to read this, if we want to start with 0 and at the end of 10 periods have 333,000 at this interest rate, what's our periodic payment? So let's now change this. Let's say, okay, we found an interest rate of 12%, and we want to come up with $500,000. Obviously, 20,320 is not going to make it anymore, because we can see that at the end we would require $46,171.82 in our account to begin with in order to come up with $500,000 at the end. We want to start with 0. So we're going to use a function that's called goal seek. It's found in the data, the what if analysis, and it's the second one there, called goal seek. And the set cell, it's very important, the set cell is the one that has the formula in it. Okay, and you recall that this cell, C16, has the present value function in it. And so what goal seek is going to do is manipulate the variables in that function to get that value to be 0 by changing one of the function's variables. And the variable that we're going to change is periodic payment amount. So I hit OK. Now watch, put your eyes right there on periodic payment. It figured out that 28,492.08 is the exact amount. I'll click off of that so we don't need to see our message. That's the exact amount that we need to come up with 0. So if we want to change our interest rate, we could do that. If I said, you know, I could ask it if I can come up with negative 30,000, just a straight 30,000 payment, what would my interest rate need to be to come up with 500,000? So I'd goal seek, I'd set my present value to 0 by changing the interest rate. And I hit OK. There we go. If I can get 10.93%, then a regular payment of 30,000 even will give me 500,000 at the end of 10 years. But that's not how it's going to work on your test. On your test, you'll have an interest rate, say 10.58, and you'd be asked to change your future value to something. Let's say I want $2 million. I've got a daughter going to be married, so I need $2 million here. To get that right, I have to go to goal seek. I have to set present value because it has all of the algebra in it. I'm going to set that to 0, meaning I don't want to have to start with any money in the account, by changing my cell that contains the payment. And there we go, $122,044.46. So practice those. Okay, it's not enough to just get good clean output on this exam. You have to understand how to do a protection here against positive numbers, and you have to know how to use goal seek to change the desired future value. So if I want to go back to this big long number here, then I would set this for 333, and I would go back to my what if, goal seek, set my cell present value to 0 by changing my periodic payment. And that's how, okay, if I were to widen this here, I could show you that what we came up with was exactly what you were given in the test. So we don't want to have to guess on something that important. And so that's what the goal seek is about. I got to stretch this until my check figure comes back. All right, so get in the habit now of just looking at your output, saying, hey, this is what I expect to see, because you are going to be graded on this exam by how well your output looks. You have to make sure that your table's not cut, and you have to make sure that you have the repeating rows. And if you can do that, then I think someday when you're out in the workplace doing your various accounting functions, you're going to get a reputation for doing clean work that can be shown right to a client. Any questions, please email me in my office, and good luck on the test.